Welcome back for more Blizzard Day activities. Today we're going to look at the surface area of a cylinder. And the surface area of a cylinder is basically the same as we have for the surface area of a prism. The lateral surface area is just going to be the perimeter of the base. But since the base is a circle, we're going to replace the P with a C for circumference times the height. And the height, recall, is the distance between the two bases. The total surface area is 2 times the area of the base. The bases are now circles plus the lateral surface area. So finding the surface area of this cylinder, we're going to start off by finding the lateral surface area, which requires that we find the circumference. Circumference, recall, is 2 pi r. And we are going to leave our answer in terms of pi for this problem. So 2 pi r, our radius is 8, so that is 16 pi. So we can plug in now to find the lateral surface area. L equals the circumference, which we now know is 16 pi, times the height, which is 12. And so we get a lateral surface area of 192 pi, and the units are square centimeters. For the total surface area, I'm again going to move off to the side and start off by finding the area of the base. Since the base is a circle, its area is pi times the radius squared, or pi times 8 squared, which is 64 pi. Plugging into the formula for total surface area, we have T equals 2 times 64 pi plus the lateral surface area of 192 pi. Which gives a final area of 320 pi, and the units there are square centimeters once again. And always make sure to mark your answers clearly with a box, a circle, or perhaps a sheep. At this time, you should pause the video and go to page 657 in your book, work numbers 9 through 16. Remember that you can access the online book if you forgot to bring your book home with you. And then come back to the video for our next example. Here we're going to be finding the radius of the base of a cylinder given the area, the surface area, and the height. So we're going to be working backwards a little bit. And so we're going to start off again with the basic formula for the total surface area. That T is 2 times the area of the base plus the lateral surface area. Now the problem with this formula at this point, though, is there's not enough detail to it. So we're going to try to fill in some detail here. We know we're working with a cylinder, so we can take out the B, capital B, for the area of the base, and plug in the formula for the area of a circle, pi times the radius squared. L, we know, is the circumference, and circumference we find by 2 pi r, times the height, and we know the height, so we'll just leave that as h for right now. Now we can take and plug in the values that we know. The total surface area, we're told, is 528 pi. Now you might think at first, why did they put that pi in there? But that's actually going to work out very nicely for us. So that equals 2 pi r squared plus 2 pi r h, but we know that h is 10, so that works out to be 20 pi r. At this point, we see why it's so important that that pi was there to begin with. It actually makes the problem easier for us because we can divide everything through by pi. And all of those are just going to cancel out. So we now have the equation 528 equals 2r squared plus 20r. Seeing the r squared tells us this is a quadratic equation. So we're going to have to solve this by either factoring or by using the quadratic formula. For this example, we'll use the quadratic formula. To use the quadratic formula, we need to get it equal to 0, and so I'm going to subtract the 528 from each side. And while I do that, I'm going to do one other thing and divide each term by 2 to make it a little bit smaller numbers for us. So we're going to have 0 equals r squared plus 10r minus 200 and 64. To use the quadratic formula, we should start off by writing the formula. X, our variable, or r in this case, equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And recall that our value for a is the coefficient of r squared, so a for this problem is 1. B is the coefficient of the r term, 10. And c is the constant, which is, for this problem, negative 264. Now we're ready to plug in the values and find r. So r equals the opposite of b is negative 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 264, and all that over 2 times 1. At this point, we might want to grab our calculator and do just a little bit of work to figure out the discriminant, the part that's under the square root sign. This gives r equals negative 10 plus or minus the square root of 1,156 divided by 2. Knowing that we want r to be a positive value, we see that negative 10 minus the square root of 1,156 is going to give us a negative. So we can just ignore that part of it and work with the plus. So we now have r equals negative 10 plus the square root of 1,156, which is 34, divided by 2, or 24 divided by 2, which is 12. And looking back at the problem, we see that our units are feet, so the radius is 12 feet. You should now turn back to page 657 and work problems 17 through 20. Remember as you work through that neatness and organization are extremely important. So make that one of your goals for this paper, to be neater and more organized than you typically are.